Now another thing to be cautious of on these parabolas is called the axis of symmetry, or the AOS. It's the line over which the graph is symmetrical or reflected over. The y-intercept, as we've talked about, is the spot where the parabola hits the y-axis, and it can be found by setting x to 0 and solving for y. So in standard form, remember we said it was y equals ax squared plus bx plus c. Well, anytime that we have a parabola, doesn't matter where it's at, where it hits the y-axis, that x value is going to be 0 right across the y-axis. So we can just set x to 0 in these cases, in which case 0 squared is 0, a times 0 is still going to be 0. Same thing, b times 0 is just 0. So our y value is always just going to be c. So you can either set x to 0, or just know that if we have standard form, our y-intercept is c. Now the axis of symmetry, again, let's say we have our parabola. Our axis of symmetry is going to be a vertical line going right down the middle, where if we look at this from here to here, it's a perfect reflection over to the other side. Same thing, here to here, it's just a reflection right across there. So the parabola is reflected over that line. Now, if you look, the AOS, the axis of symmetry, goes right through the vertex. And so vertical lines, as we remember, are always of the form x equals. So it looks like x equals the x value of our vertex. So we know that always the axis of symmetry is our x value of the vertex, which we said from before was negative b over 2a. So in this case, or in any case, our axis of symmetry is just x equals negative b over 2a. So let's put this into practice and see what we can find here. So if we're considering the quadratic function 2x squared plus 2x minus 3. Well, remember our y-intercept is always at the spot 0, c, so it would be 0, negative 3. Our axis of symmetry, I'm going to do this one in green. Remember, our x value of the coordinate, or our x-coordinate of the vertex is always negative b over 2a, which in this case, b is 2, so we'd say negative 2 over a is also 2, so 2 times 2, in which case we have negative 2 over 4, which reduces to negative 1/2. So that is the x value. So our axis of symmetry is at x equals negative 1/2. The x value of the, or the x coordinate of the vertex, which we found over here, is just the negative 1/2. So we can get rid of this work, get that out of our way. So we found these properties out of our parabola. So let's check these all by graphing. Again, in this case, according to what we have here, our axis of symmetry is at negative 1/2, so it looks like it's supposed to be right here. So if we know that our vertex is supposed to be there, we'll put our vertex right in the middle of our table. Then we'll say the next smallest whole or integer would be negative 1, and then negative 2. Same thing will go the other way. The next biggest integer would be 0 and 1. So now we know that these are good values to be using for our table. Once we have these values, plug them back into our function. So we'd have 2, I'm going to use the negative 2 first, negative 2 squared plus 2 times negative 2 minus 3. So I'm just plugging this value back into the function. From here, negative 2 squared is 4 times 2 is 8, plus 2 times negative 2 is negative 4, minus 3. So 8 plus a negative 4 minus another 3 is going to leave us with 1. So we'd have 1 as our value here. Same thing, I got to keep going and try some other values here. we'd say 2 times negative 1 squared plus 2 negative 1, 2 times negative 1 minus 3. Negative 1 squared is 1 times 2 is 2. Plus 2 times negative 1 is negative 2. And minus 3. Positive 2 and negative 2 cancel out, so we're just left with negative 3. This is where it gets a little bit trickier. Now we are plugging in a fractional value. So in this case, we would say 2 times negative 1/2 squared plus 2 times negative 1/2 minus 3. Negative 1/2 squared is negative 1/2 times, negative 1/2. Negative and negative make a positive. 1 times 1 is 1. 2 times 2 is 4. So it's going to be 1/4. So that's negative 1/2 squared is 1/4. Times 2, we'd have 1/4 times 2, which is the same as 2 over 1. Multiply right across, so we have 2 over 4, which reduces down to 1/2. So this one is positive 1/2. 2 times negative 1/2 is going to leave us with a negative 1, and still our minus 3. So our two negative numbers will become a negative 4 plus this 1/2 leaves us with a negative 3.5. So that one was our tricky one because that one had our fractional value in it. The other ones should come out fairly easy. We'll plug 0 into our function, so we have 2 times 0 squared plus 2 times 0 minus 3. 0 squared is 0 times 2 is still 0. 2 times 0 is, again, 0. Subtract 3. So we're left with just a negative 3 here. And our final one, we would say 2 times 1 squared plus 2 times 1 minus 3. 1 squared is 1 times 2 is 2. 2 times 1, again, 2. And minus our 3. 2 plus 2 is 4. Minus 3 is 1. And now we found the values that we've been looking for. So if x is negative 1, 2, our value is 1. When x is negative 1, we're at negative 1, 2, 3. I can get rid of these ones. When x is negative 1/2, so right on that axis of symmetry, we're at negative 3 and another little half there. When x is 0, we have negative 3 is our y. And when x is 1, our y is 1. So in this case, our parabola looks to be something like this. Again, according to our table, looks like our vertex is right here. Let's say V, our vertex is at negative 1/2 and negative 3/2. So it would be negative 1/2, negative 3.5 is our vertex. So the x-coordinate of that vertex right here is what we found right there. The axis of symmetry goes right through there, which is what we found out from before. And our y-intercept looks like it crosses right at this point, which is 0, negative 3, which concurs with what we said before. So it looks like all of our tricks from the standard form worked out.